Welcome back, everyone. To complete this section of the course, we're going to briefly discuss Tensorboard. Tensorboard is a visualization tool from Google designed to work in conjunction with TensorFlow to visualize various aspects of your model. Here, we will simply understand how to view the Tensorboard dashboard in our browser and analyze an existing model. A really important note here is that this lecture requires that you understand file paths and the current location of either your notebook that you're working in or your .py file. So keep that in mind. We did review some of these topics in the Pandas input and output lecture, so you may want to review that. Now keep in mind, Tensorboard is technically a separate library from TensorFlow. So if you aren't using our environment file, you may need to pip install or con install Tensorboard in addition to TensorFlow. If you're using the Google Colab notebook online, the Google official guide actually has a pre-made notebook that you just run all the cells and it automatically uploads Tensorboard for you. I have the URL here, but we're also going to just show you how you can find that, and we link to it in our notebook. Or you can just Google search Tensorboard in notebooks and it'll have that link as well. Okay, let's get started by heading over to our folder from our zip file. Okay, here I am underneath the ANNs folder. Go ahead and open up the Tensorboard notebook that we have here for you. It's 05-Tensorboard. What we're going to be doing is we're going to be creating a Tensorboard running off the network we originally created in our Keras classification lecture. So once you open up that Tensorboard notebook, it should look something like this. And there's a link here for the full official tutorial that discusses a lot of cool aspects of Tensorboard. We're really just going to be going over the basics in this particular lecture. But if you click on that link, it has this Getting Started link, and what's really cool about this is if you're using Google Colab, all you need to do is you can essentially almost skip this lecture, just open up this link that says Run in Google Colab, and it has this Getting Started with Tensorboard notebook that you can essentially run all the cells, and it has everything done automatically for you. Keep in mind, it's going to be using a slightly different model here. It's doing an MNIST convolutional neural network that we'll see later on in the course, but the same ideas are the same. You'll create a log directory, create some callbacks, and then fit it. And we're going to be going over this as well in our lecture right now. So you can go ahead and watch our lecture and then just click on this link and then run this notebook, and you should be able to actually see Tensorboard inside of your notebook. So let's come back here and we'll show you how to run this if you're running it locally. Again, if you're on Google Colab, pretty much just click on that link and start running the cells. But we're going to import pandas and PD and NumPy, read in the data file that we worked with, that cancer classification. We'll go ahead and grab those values, perform the train test split, and then scale the data. So far, nothing different. And then we'll also create the model. So we'll create the model. I'm also going to add in the early stopping. But one thing to notice here is that we're importing an additional callback. So from keras.callbacks, you will also be importing Tensorboard. So even if you don't import early stopping for your particular model, in order to actually compile and have Tensorboard keep track of those logs, we're going to, from keras.callbacks, import Tensorboard. We'll go ahead and create the early stopping callback just as we did last time. And then we're going to make sure we understand where this notebook is located by running pwd. So in my case, I have now the file path of where this notebook is actually located. All right, so now it's time to actually get to probably the most important part, which is creating this Tensorboard callback. So again, Tensorboard, it's that visualization tool, and what's going to happen is this callback that we're going to create with this Tensorboard import, it's going to log a bunch of things, and it's up to you what it logs and what it doesn't log. So it can log things like a training graph visualization, activation histograms, sample profiling, metric summary plots, etc. So there are various arguments that you pass when creating your Tensorboard callback variable to indicate whether or not you want to record something. So the most important one is right here, log directory, which is essentially the file path to the logs. And we'll show you how to fill that in just a second. The other ones are just whether or not you want to keep recording something. So the histogram frequency is the frequency in epochs at which to compute activation and weight histograms for the layers of the model. So what we're going to do is we're going to set this to 1, so that basically after every epoch of training, we'll go ahead and calculate all the weights for our layers, and then we'll create a histogram of it. And then the next epoch, we'll do another histogram. So we'll actually be able to see these histograms essentially stacked on top of each other, and we'll get this kind of cool 3D visualization that shows how the weights are essentially changing throughout the epochs of training. And then if you want, you can also visualize the graph itself. So we can set write graph, and we can set that to true. We can also decide whether or not we want to write images. So whether to write model weights to visualize as an image in Tensorboard. And then the update frequency is also something you can choose. Typically, I would recommend updating per epoch. It's usually easier to interpret that way. And then finally, we can also specify a profile batch. So we can profile the batch to sample compute characteristics. By default, we can profile by the second batch, so we'll keep it on that default. And then embeddings frequency is the frequency in epochs at which embedding layers will be visualized. If you set that to 0, you won't bother with visualizing those embeddings. So lots of different things there. The other thing to note here is if you're running this model multiple times with different parameters and you want to make sure you have different directories for each time you run this model, what I recommend doing, and this is also the exact same thing they set up in the official tutorial, you'll notice as you scroll down, they'll set it up with a date timestamp. So right here, they call date time. Essentially what that does is if you say from date time, import date time, and then you say, let me just zoom in here so you can see this clearly, datetime.now, and then structure the time with this particular command, you'll get this string, which indicates today's date and the hour. And what you can do is have that be the name of your folder. That way, as long as you wait 1 minute before running your model again, you'll have a unique log for each time you run the model. That way you can go back, edit the number of neurons in a layer, etc., and visualize each of those models with Tensorboard. Now, in our case, we're only going to run this one time, so we'll go ahead and just set our log directory to logs, and since I'm on Windows, I'll say \\fit. If you're on macOS or Linux, you may need to do just one backslash or even a /. What I recommend doing is, if you come back up here, notice after you type pwd, it actually reports back to you the syntax you should be using. So I should be using double backslashes. So that's what I'm going to do down here. So your log directory, the base of it should always be logs, and then the next subdirectory should be fit. So after I run this, inside of my current location, this ANNs folder, I will end up seeing a folder called logs be created, and then a folder inside that called fit. So we must say logs fit, and then optionally, you can add a timestamp for a unique folder. So this is the code that automatically does that for you. Okay, so right now I have this variable, log directory, which is essentially saying, where am I going to save these logs during training? And by default, it should be logs fit. So I pass that in as my log directory. I'll say histogram frequency is 1, and then we'll go ahead and say write graph true, write images true, update the frequencies every epoch. We'll keep profile batch to 2 because that's the default, and then embeddings frequency, we'll keep that at 1, and you can play around with these options as well based off what you read here and what you actually want to record. So we'll go ahead and create that callback, and now, just as before, we'll go ahead and create the same model. You actually don't need to edit anything in your model, so we'll just run that model just as we did before. Where you actually add this in is underneath our callbacks list. Instead of just passing in early stop as we did before, we will also pass in this variable board, which recall is this Tensorboard callback that we just created. So after you create the model, go ahead and fit the model. Okay, so this is going to be training, and because I have early stopping here, it shouldn't be training for the full 600 epochs. I think last time it stopped at a little over 120. So we'll just go ahead and let this run for a little bit, and eventually it should stop training once it reaches somewhere above that. So okay, so here's 126, early stopping, perfect. Okay, so now we're going to run Tensorboard. So instead of running our own visualizations, let's see what Tensorboard has to offer. The first thing to note here is that Tensorboard is going to be running locally in your browser at localhost 6006. Go ahead and click that and open it in a new tab. Now, because we haven't actually run Tensorboard yet, when you run that, it should just be empty. It'll say something like, this site can't be reached, because Tensorboard's not running on that yet. To actually run Tensorboard, what we're going to do is we're going to run it through the command line. The main thing to keep in mind is, what was your log directory? Recall that's the variable we made that essentially indicates where we're actually saving our logs. Recall that we saved it under logs fit. In fact, if you come back to the ANNs folder, you'll notice we now have this logs folder, and underneath that, there's a fit subdirectory, and underneath that, there's train, validation, and the special file for Tensorboard. And these are essentially raw files that Tensorboard is going to use to display visualizations. And there's more files depending on how much you're actually recording. Okay, so the main thing to keep in mind is what was your log directory? In our case, we kept it simple. It's just logs fit, but you may have a longer timestamp associated with that as well. And then the next thing to recall is where you're actually located on your computer. So this is where I'm located on my computer. So what we need to do is go to our command line. That's either the Anaconda prompt or the command prompt for Windows users, or for Mac OS or Ubuntu or Linux users, that will be your terminal, or the Anaconda prompt if you installed that as a Mac OS or Linux user. Let's go ahead and open up our command line. So main things to keep in mind is where is this file currently located and what the name of our log directory was. Okay, so I will open up the Anaconda prompt, and now I have my Anaconda prompt open. The next step is to make sure that my course file or course environment is activated. So I will say conda activate, and then whatever the course environment happened to be called. In my case, I use a slightly different environment while I'm filming these lectures. So I will say conda activate TF2 GPU. However, your course environment will be the one you set up during the installation lecture. You should have already been activating your environment as you've gone through these lectures, so this shouldn't be new to you. Okay, so you've activated the environment, and now what we need to do is we need to change directory or CD into this particular folder that was typed out during PWD. So I will CD into these Purion Data courses. That's where I happen to be located. Your files may be different on your computer. And I would highly recommend that you just tab autocomplete this, because if you spell anything wrong, it won't work. Then type CD again, and the next folder, in my case is TensorFlow 2 Bootcamp. Again, just use tab autocomplete to make sure you're spelling this right. And then finally CD into 03 ANNs, and there we have it. Okay, so now it's time for the command. So the command we use is make sure you've activated your environment. You should be able to type Tensorboard space -- log dir space and then your log directory. So in my case, my log directory, I printed it out here, was logs \fit. So that will be logs \fit. And if you want to see it all in one line, I can stretch this out. So here it is. So the steps was to activate my environment. Yours may be called different depending on your install lecture. Then CD into that folder where I happen to save those logs or where that notebook was running, and then run Tensorboard space -- log dir space, and then the file path that was printed out when you printed out log directory up here in the notebook. Then go ahead and hit enter. Upon hitting enter, you should see some commands pop up, and eventually what's going to happen is it's going to tell you, hey, Tensorboard's running at localhost 6006. Recall that's the URL we opened previously. Whatever you do, do not hit Control+C, so don't do Control+C to copy this localhost, otherwise that actually quits this. So only use Control+C when you're ready to quit. What we're going to do is we're actually done with the Anaconda prompt for now. So we're going to come to our book in the browser. Recall that we already opened localhost 6006. Go ahead and open that tab again. And if it says this site can't be reached, you saw it for an instance there, just refresh and you should see it pop up. And just in case it doesn't, you can always come here and then select scalars. However, if you did everything like I did, it should have automatically gone to scalars for you, as you can see here in the URL. Okay, so let's explore some of these. I will zoom out just a little bit so we're not super zoomed into this Tensorboard. And to start off, we can see our loss both on the training set and our validation set. And we get this really nice interactive plot, and we can make it very smooth if we want, just to get the general trends. This is probably a little too smooth, or we can turn smoothing completely off to get the raw data, as we've done before. So this is essentially an interactive version of the plots we were making before with pandas. And we can start playing around by toggling the y-axis to be logarithmic. We can turn that off and on. We can also fit the domain to the data. It actually does that automatically. And then you can also do things like make it larger and zoom in. So lots of different things to play around with. If you only want to see validation, you can do a checkbox here to see it, etc. So this is what we see under scalars. You can explore that. Then we have images. In our case, we did actually decide to record these images. And this is essentially showing you the images weights. And as far as interpreting this, for our particular set, since we're not dealing with image data, it's not very clear how to interpret this. This is essentially the weights as they get kind of darker or lighter, depending on what actual layer you're on. So we can see here the mapping. But overall, interpreting this isn't going to help us that much because we're not actually dealing with image data. And you can also play around with the contrast, etc., as well as the brightness. Then there's the graph itself. So this is the graph we created that you can play around with. You can explore it. There's a legend here showing you what each of these nodes are doing, but here's the sequential model that we created. We can expand on that. We can see here what we created, etc. Then there's the distributions, the range of weights throughout these different layers. So dense 1, dense 2, and then the final one. Keep in mind, as far as interpreting these directly, it won't really help you that much for this particular data set. This becomes a lot more helpful when you're dealing with things like convolutional networks. We can also see the histograms. Again, as far as interpreting this directly, maybe not super useful, but something you can tell here is how much things are changing throughout time. So for example, if we just take a look at this first dense one, this is the bias right now. So these are the bias values per epoch throughout time. So you can see in the very beginning, they're kind of changing wildly, but as you start to get towards the stopping epoch, notice they're not changing that much. These histograms of these bias values is not changing, which makes sense. We should expect that as we get closer and closer to that early stopping point, things are changing less and less. And it's the same for the actual weight histograms as well. So these are histograms, in this case of bias and the weight for that first dense layer. So you can see they start changing rapidly in the beginning, but then they start settling down towards whatever their final weight's going to be. And we can view that for the layers. Okay. And then depending on what you decide to record, you can view things like profile and projector. These aren't going to be super useful for us right now, so we'll go ahead and skip these. And we'll come back to Tensorboard when we're dealing with convolutional neural networks, because then it's going to be really helpful in exploring the network. But for right now, we can see that we've actually already created a lot of these images ourselves, specifically the epoch loss. That's the one that really you're going to use a lot, and we already know how to create this on our own. These histograms, while they're kind of interesting to look at, for right now, there's not much you can do as far as editing the hyperparameters on this artificial neural network just based off these diagrams. As you get more advanced, you can interpret these a little better, but for right now, the main idea here is that you know how to create Tensorboard, and we're going to come back to this and explore these in more detail as we learn about more complex models where interpreting these graphs can really help us. Okay, thanks everyone, and I'll see you at the next section of the course.